Hello class, this is lesson 3.5. We look at the absolute value function, and we will look at equations and inequalities that have an absolute value in them. So this is the definition of absolute value. We use these vertical bars. So say capital A is some algebraic expression, and then the absolute value of A either equals A if A happens to be positive, or we put a minus sign in front of it if A was negative. And therefore the output is always greater than or equal to 0. So for example, if we plug in the number 3, 3 is positive, so absolute value of 3 equals 3. If we plug in negative 3, well, negative 3 is negative, so we get negative 3, we get positive 3. If we plug in 0, the absolute value of 0 is 0. Now I drew this number line here to give you another interpretation of the absolute value. So here's negative 3 and 3, which we just took the absolute value of. Notice how both of these numbers are a distance of 3 to the number 0. So the distance from negative 3 to 0 is positive 3. The distance from 0 to 3, positive 3. So really this absolute value is sort of measuring the distance from a number to the number 0 on the number line. So when we look at the most basic type of equation, like absolute value of x equals 3, well, from the above number line, we know these are the two solutions, right? This could either be interpreted as we are the positive distance of 3 from some number x over the negative direction of 3 units from 0 to x. Right, so when solving these equations, if the absolute value is already by itself on the equal sign, we just set up these two equations and solve. But if the equation is a little more complicated, like we have x plus 3 inside of the absolute value, then we break it up as follows. If we have absolute value of x plus 3 equals 2, we break it up into x plus 3 equals 2, or x plus 3 equals negative 2. Sort of allowing for the two cases, either this, we're talking about this direction or this direction on the number line. So then we just solve these two equations and get the two solutions for the problem. So typically we will have two solutions in these type of problems. And let's look at a little more complicated example. Say we have absolute value of 9x plus 1 minus 14 equals negative 5. So here the absolute value is not by itself on the equal sign, so we get rid of this 14 by throwing it on the right hand side. And now the absolute value is by itself. So we could break it up into the two equations, where one equation we just ignore the absolute value. The other equation, we ignore the absolute value, but we put a minus sign on the one or the other sides of the equation. You can put it on the right-hand side or the left-hand side, doesn't matter. We just solve these two equations and get the two solutions. So that is how we deal with the absolute value equations. Let us now turn our attention to inequalities, which are a little more complicated. So when we're doing with inequalities, we could either have something like this, or we could have something like this. Okay, so we could have a less than or greater than type of problem. First, let's look at problems of this form. They are a little bit easier. And then we will look at some problems like this. So let's just try to interpret what this means. Let's start with a really easy one. Say x less than or equal to 2. Absolute value of x is less than or equal to 2. Well, let me draw a number line here. 0. There's 2, here's negative 2. If absolute value of x equals 2, that means we're dealing with either one of these two numbers here. But what does it mean if an absolute value is less than or equal to a number. Well, that's like saying the distance from 0 to x is less than or equal to 2, right? Well, on the number line, we know that's all of these numbers, right? Any number in this interval, -2, 2, will have an absolute value less than or equal to 2. Like, for example, if I picked the number 1, the absolute value of 1 is clearly less than 2. So if we pick any of these numbers here in red, that will solve the problem. So when we're dealing with an inequality of this form, our solution will typically be an interval of this manner. Let's look at another example. So say we have x plus 1 less than 3, strictly less than 3. Okay. Now we could sort of break it up into two problems like we were doing earlier. We could either do x plus 1 less than 3 or x plus 1 greater than -3. So here I multiplied by a negative, which is why I flipped the symbol. So in absolute value inequalities, we can break it up into two inequalities, but we have to be careful. This inequality, we just ignored the absolute value symbol. So this is the case where we just assume everything is positive and the absolute value symbol is irrelevant. But in this case, we multiplied one side by a negative, so we had to flip the symbol here. And now we just solve these two problems here. X is either less than 2, x is greater than -4. Okay, so it may help to draw a number line. Here's -4, here's the number 2. So we're saying we're less than 2, so these numbers less than 2, but greater than -4, so it's going to be these numbers here, -4 to 2. And I used open parentheses here because we had a strict inequality. In the previous example, we did include equality, so that's why I used the square brackets. Okay. So again, when we have problems like this where it's of this format, our answer will either be a closed interval or an open interval. Let's now look at an example like this where the absolute value is greater than or equal to some number. In this case, we'll typically have a union of intervals as our solution. So we could start easy, say x is greater than or equal to the number 2. So if you want to solve this just graphically, you can look at all the numbers that have an absolute value greater than or equal to 2. And that's obviously these numbers, -infinity to -2, or 2 to infinity. But if you wanted to solve this algebraically, you could set it up as two problems. One problem you ignore the absolute value. The other problem you flip the symbol and multiply by a negative on one side, which does in fact give us the same solution. Okay? So if we look at a more complicated example, say x plus 3 greater than 1, well, we could break that up as x plus 3 is either greater than 1 or x plus 3 is less than -1. So we get the following solutions. X is either greater than -2 or x is less than -4. And if we want to put this in interval notation, it may help to make a number line here. So there's the number 0, there's -2, there's 4. So this is saying that we want numbers less than -4. This is saying numbers greater than -2. So our solution is minus infinity to -4 or -2 to infinity. Right, so when we deal with problems of this format, our solution will typically be a union of intervals. Right. And that is how we deal with these problems. Okay, so that concludes today's lesson. Thank you.